I'm Ava Malysa.
And my name is Samantha Palmadessa, and we researched electrocoagulation with aluminum, copper, and zinc for aqueous methylene remediation and sustainable energy production. Living on Long Island near numerous bodies of water, water pollution is a visible issue that we see on a daily basis. Global water pollution and unsustainable energy production are two growing and harmful issues. We researched a solution to both these problems, allowing them to abet each other through electrocoagulation for dual water remediation and sustainable energy production.
In the process of electrocoagulation, electricity moves into the positively charged anode and oxidizes water by removing an electron, creating oxygen gas and hydrogen ions. The removed electrons are conducted back at the negatively charged cathode to create hydrogen gas, which can be captured and used to produce green energy. The process also produces coagulants that settle out and rise up pollutants into sludge and flocks to be filtered out. In this experiment, we researched the optimal conditions for electrocoagulation by testing varying electrode metals, contact times, and stir rates.
We created a 3D printed lid to simultaneously assist in aqueous dye remediation and phenyl hydrogen gas. The lid was designed in CAD Onshape with specific measurements to allow for a tight fit and minimal hydrogen gas leakage during experimentation.
Thin slots were included in the design to hold the electrodes in place 1 centimeter apart and parallel to each other and the sides of the beaker to maximize electrocoagulation efficiency.
There was a small hole in the center of the lid for silicone tubing and hydrogen gas collection. Hot glue was added to ensure that the setup was airtight. Hydrogen gas was funneled from the setup to a mini PM fuel cell for collection and measurement after 1 and 5 minutes.
The constructed electrocoagulation system was highly successful, reaching a peak of 100% remediation after 5 hours at 30 RPM with copper electrodes, and producing enough energy to power 11.62% of the treatment. The constructed system works in remediating dye from water that is clean or polluted with other contaminants, since the redox reactions separate and combine the hydrogens and hydroxides separately from the flocculated dye.
Overall, our electrocoagulation system's ability to fully remediate methane blue contaminated water from any system while producing enough hydrogen gas to cover over 11% of the power required for the process shows that there is great potential for real world application, especially in developing countries. Electrocoagulation's efficiency, accessibility, and low cost can make the world cleaner and healthier. Thank you.